So we start the problem with, we have a woman whose mass is 55 kilograms. So, and she's on both the Earth and the Moon. So, is that a person? This is the Earth. And her forces is, there's force of gravity and normal force. So, and then we got the Moon. Alright. So we have the givens and finds. There's so we know that the woman is 55 kilograms. We know that the acceleration on Earth is 9.8 meters per second squared. And we know that the acceleration on the Moon is 1.6 meters per second squared. 62. And then the things that we have to find are her weight on the Earth, weight on the Moon, and then her mass on the Moon. So,
All right.
So the first thing we have to do is find the sum of the forces.
So, sum of force in X is equal to 0, and sum force Y is equal to 0.
Force in the X direction doesn't matter because there are no forces in the X direction. And the forces in the Y direction, we have the force of the normal and minus the force of gravity, and
And those equal 0.
and those they're equal to each other, so they equal 0. So that's the sum of our forces. So we also need the free body diagram. So we have over here force of gravity, force of the normal, and it's the same over here. Force of gravity and force of the normal. For finding mass on the Moon, mass is a constant, so mass on the Moon equals mass on the Earth. So mass on the Moon is still 55 kilograms. For finding the weight on the Moon, we will find the sums of the forces. Right, again, yeah. So force in the X is 0. Sum of forces in the Y are 0 again. Again, X, there's no movement or no forces, doesn't matter. For force in the Y, we have the force of gravity minus the force of the normal, which they are the same, they equal 0. And the force of gravity on the Moon is 1.62 meters a second squared, so the force of the normal is 1.62 meters a second squared.
Yo.
So we have 55 kilograms times 1.62 meters a second squared, which equals 89
Of course, easy mental math.
newtons. I did that in my head.